Okay, welcome back. Today we are going to finish up this lecture on numeric variables. So, we'll start off by talking about arguments and parameters. Okay. So, when you're calling a method, you can always send an object or a primitive as an argument. For example, in the method call, do this in Notepad. If I'm calling a method, the method exists somewhere in class definition as void method, and maybe it takes a string s. And here's the method, and some statements go here. In another part of the program, I can call that method by saying method and send along either a string that's a literal, or I could have something like string s equals new string word. And then I could send along s as the argument. Okay. So, the tricky part is that the types you send along have to be compatible with the parameters in the method header. For example, if I have a method in a class that accepts an int, void method int x, and again, statements go here. In some other class, I can call that method. I can send along a variable. For example, I could send along byte b equals 120, and I could send along b with that method call. Reason is by automatic promotion, so I can always promote a byte to an int because every value that's possible for a byte can also be stored in an int. I don't risk losing value. On the other hand, if I have a double D equals, say, 120.0, I can't send that along. If I try to do this, I'll get an error because what will happen is if I send along a double to this int method, it'll have to be demoted. The only way I can do something like this is if I typecast it first. And by that, I choose what data I'm going to lose. In this case, by typecasting it to an int, I lose the decimal point and everything after it. Okay, so likewise, for objects, any subclass argument is compatible with a superclass parameter. So, if I have a method, suppose I have two classes. I have a class, I don't know, object 1 that has whatever it has, some data fields, whatever, and methods. And I have another class, object 2, that is a subclass of object 1. Again, some data fields and methods. Now, if I have a method that expects to receive an object 1 object, and I'll call that obj, I can send along an object 1 with the method call. I can call it by method. All right, I can have object 1 obj1 equals new object 1, and I can send along obj with the method call, and that's obviously fine because it expects to get an object 1, and I'm sending an object 1. But by inheritance, another thing I can do, there should be object 1 there in the first place, I can always send a subclass. Reason is every object 2 is in fact an object 1. It's just like if I have a class vehicle with subclass car, every car is still a vehicle. Likewise, every object 2 is still an object 1. Everything that an object 1 can do, an object 2 can do. It's going to have the same methods and the same data. So this is also perfectly fine. I can essentially use a type of promotion. I can say that, well, every object 2 has all the things that an object 1 has, and thus it's okay. All right. So in the examples I have here in the slides, the first thing, if I have given void method int x double y, this method expects to receive an int and a double. So if I call the method with sending along two ints, 6 and 7, that's fine because 6 is an int and 7 is also an int that can automatically promote to a double. There's no problem. But if I call it sending along two doubles, well, 7.0 is a double, there's no problem. But 6.0 going to an int, that's a demotion. I would have to somehow convert this to an int before I could call the method with that value. Okay. Now, key point about parameters, and this is just a little bit of how Java works, so if it seems confusing, the best thing to do may be to push the I believe button. So, if we have two different cases, I'll give one, send numeric variable as argument, and the other, send object as argument. Okay, if I call a method, for example, I have a method over here, I'll just write it over here, void method 1, and expects to get an int x. Okay, and something happens here. I'll say statements. I'll clear that up a little bit. Okay, if I call method 1, and I send along a variable, let's say over here I have an int value equals 6, and I call the method, I send along value, and then something happens here, perhaps x equals 1 million. Okay? At this point, after returning from method 1, the value of value is unchanged. It's still 6. Reason is, everything that happens, well, the easiest way to say it is, when you send a primitive to a method as an argument, the receiving method creates a copy of it as the parameter. So you're not actually sending along a reference to the same point in memory. You're just saying, oh, you're sending along a number with the value 6. Great. Over here, I'm creating an entirely separate number called x. I can do whatever I want to it in the method, and it's not going to change the original value I sent x. Okay, so for primitives, changes to a parameter in a method do not affect the original variable. Okay, so that's just how Java works. So anytime I send along a primitive to a method call, I'm creating a copy of it, and thus the changes that might happen in the method are only happening to the copy, not to the original. Okay, on the other hand, suppose I send along an object as an argument, and I'll do a similar thing here. Suppose I have an object, again, I'll call it object 1. So object 1 obj equals new object 1, and I call method 2 and send along obj. Okay? So if I have void method 2 and expects to get an object 1 called obj, well, I'll call it, just to keep it clear, object 1. And within this method, I might say something like object 1 dot field 1, say it has a field 1, whatever is some int, and I say it equals 12. Well, let's do that. If I do it over here, I'll add in a follow-up statement, obj dot field 1 equals 6. Okay, and let's line that up. At this point, after the method call, obj.field1 will actually equal 12, because for objects, the changes in a method do affect the original. Okay, that is to say, anytime you send an object as an argument, the method deals with the original object, not a copy. You don't create a copy in the method for objects. So, any changes in the method do affect the original. Okay, and if you want a sense of why this works this way, why it is different for numeric variables versus objects, it's simply this. Primitives are small, not much memory space. So creating a copy is a pretty trivial activity. Objects, however, could be very large. In fact, depending on the device you're using, if you're using some small embedded computing device, you might not even have enough memory to create the second one. So, by default, Java uses the original. Okay, having said that, there are ways that you can send along the same primitive, and the simplest way to do that is to just create an object that holds that value as a field and send along the object. Or if you want to create a copy of an object, there are methods that you can use to create a new copy of the object and have it work separately. But in general, by default, when you send a primitive to a method, you're creating a copy, so any changes don't affect the original. When you're sending an object as an argument, you're not creating a copy, you're just referencing the original one. So any changes that happen within the method do affect the original. Okay, a couple more things, then we'll be done here. So, numeric constants. In Java, the reserved word final before a constant, before a numeric variable, indicates that the variable is in fact a constant. So if I do this, if I have final int x equals 6 in my code, then x is a constant. I can never change the value of it through the course of the program. Likewise, if I have a double y and I label it with final, then it's forever and ever 8.2. Any variable designated as final cannot be changed. Okay. Other stuff, math library. Won't ask you about this on the exam, but it is useful in case you need to do some little bit more complicated math than what we do. So Java has a core math class in its language, java.lang.math, and all these functions are things like trig or exponentiation, some simple ones like math.abs for absolute value. And they're automatically accessible without any import statements. So you can just call math.pow or math.log to calculate the exponent or natural logarithm of a particular variable. And you can look those up. And they're, if you look up the various math functions, you can always find what you want to do. Okay. So, simple example, absolute value accepts a number. In this case, it's a double, so ABS will return the value of D. And this is an example of rounding a double to a nearest integer. So, if it is a positive number, we want to round up if it's 0.5, if the decimal part is 0.5 or greater. If it's a negative integer, we want to round down if the value is 0.5 or greater. So essentially what we're doing is we're returning an int. So whatever D is, we add 0.5 times D divided by its own absolute value. So if D is positive, we're going to add 0.5. For example, if D is 6, we add 0.5, right? Suppose their number is 6.5. D is 6.5. We add 0.5 times D divided by itself, or just 0.5. So it becomes 6.5 plus 0.5 equals 7, and it returns 7. On the other hand, suppose D is negative 1.5. Well, we have negative 1.5 here. D divided by its own absolute value is negative 1. So we're going to add plus 0.5 times negative 1, which is going to round it down. So we have negative 1.5 minus 0.5 equals minus 2. We'll round it down that way. Okay. So, last stuff you need to check, things that you should know at the end of this chapter. Number 1, what are the 6 numeric types, their approximate range, and their precision order? I'm not going to ask you for exact endpoints, but you should know that an int can hold numbers far larger than 100. You should know, for example, that a byte can't hold a billion. You should, of course, also know their precision order. Next, you're going to need to know the 5 arithmetic operators and their order of operations. Know demotion and promotion. When are they valid? So short version there, promotion is always valid. Demotion, you have to be explicit and say, I want to demote this by typecasting. If you just try to do it by saying something like or int x equals 6.3, that's going to be an illegal demotion. You can't do it implicitly. You have to specifically say int x equals typecast to int 6.3. Next one, how are mixed expressions evaluated? Well, anytime you're doing a calculation, if it's an intermediate calculation or a final calculation, if the expression involves two different numeric types, the result is always in the form of the highest precision type. So for example, if you have an int plus a long, the result is a long. If you have an int times a double, the result is a double, and so on. Last, how are objects and primitives handled differently when sent as method arguments? Well, a primitive that you send as an argument, the method that receives it as a parameter will make a copy of that primitive. If you send along an object, the method that receives it as a parameter will use that very same object. The parameter reference will point to the same spot in memory as the original. So if you change something in the parameter object, you'll change the same value in the original object. And if you understand all that and can apply it and are a little bit careful, you should be fine. All right, that's all for now. Thanks.